So let's apply what we've learned. So at this point, you should have already tried these 4 problems. And this is a combination of our first lesson, factoring GCF and factoring trinomials. So let's see how we did. So in the first one, you've got 15x cubed y minus 35x squared y squared plus 40x y cubed. Now, we do have a trinomial, but notice that it doesn't look like the form that we've been used to seeing as far as the lesson from yesterday. And always, when we start with factoring, we always want to start with our first step, which is to always look for a GCF. So in this example here, let's start with a GCF. Look at these 3 terms, and do you notice anything? Do they have anything in common? And the answer is yeah, they do. I see x's and y's in all 3 of those terms. I also notice that they're all divisible by 5. So factoring out and starting with a GCF. So if we're not sure how to find our GCF, what we can do is we can take each term individually and break it down into factors. So 15. 15 breaks down to 5 times 3. And then, of course, I've got the x, and the x, and the 1y. Okay, 35x squared y squared. 35 breaks down into 5 times 7. And then I have the x, and the y. 40 breaks down into 5 times 8. 8 breaks down into 2 times 4. 4 breaks down into 2 times 2. So 5 times 2 times 2 times 2 gets me 40. Then, of course, the 1x followed by the 3y's. So how do I know what my GCF is? So I circle all of the terms that they have in common, or all of the factors that they have in common. So notice how we have, each of them have a 5 in common. Notice how they each have at least 1x and at least 1y. So what is my GCF? My GCF is 5xy. So what's going to go inside of the parentheses? So 5xy times what gets me 15x cubed y? 3x squared. See, 5 times 3 is 15. X times x squared is x cubed, and then the y. So then 5xy times what gets me negative 35x squared y squared? So that's going to be negative 7x. Because 5 times 7 is 35. X times x is x squared, and y times 1 is y. 5xy times what is going to get me 40x y cubed? 8y squared. Because 5 times 8 is 40, x times 1 is x, y times y squared is y cubed. So I have successfully factored out a GCF. So what about the second one? Well, in number 2, if you already see what the GCF is, you already can tell they're both divisible by 5 and they both have an x in common. My GCF is a 5x. There's really no point in this step here. This just helps to break it down to help you find the GCF. So I have my GCF. So 5x times what is 45x squared? 5 times 9 is 45, and x times x is x squared. 5x times what is negative 20x. 5x times negative 4 is negative 20x. So I factored out my GCF. I have dimensions of 5x by 9x minus 4. Number 3, well, we do not have a GCF, and we have a trinomial, and more importantly, we've got a quadratic trinomial. So for this one, I'm going to set up my 2 by 2 box. Okay, so my x squared is always going to go here. My 35 is going to go here, my constant. So quadratic term goes in the first box. The constant always goes in the last box. And my two diagonals are my linear terms, so something x and something x. Now, for this one's not going to be as challenging because of the simple fact that I do not have a leading coefficient in front of that x squared, because the only dimensions that can possibly be is x by x. X times x is x squared. So now, factors of 35. So 1 and 35, 5 and 7. So which one is it going to be? The 1 and the 35 or the 5 and the 7? Well, which one is going to be the only two that I can put together to add to negative 12x? Has to be the 5 and the 7. Now, because it's got to add to negative 12 and multiply to positive 35, then both the 5 and the 7 have to be negative. And so then now, x times negative 5x, x times negative 5 is negative 5x. Negative 7 times x is negative 7. And when we combine them, we add to negative 12x. So my dimensions, or my factors, are x minus 5 by x minus 7. Okay, so in number 4, again, 3 terms here. It's a quadratic trinomial, so I'm going to go straight to my 2 by 2 box. I always want to look for a GCF, but unfortunately I don't have one. 5x squared goes here. The negative 3 goes here, and these are going to be my linear terms, so something x and something x. So these two have to add to negative 2x. So because I've got a leading coefficient with the 5x squared, I've got some options that I have here. And the truth is I could still use a guess and check approach to this one, because you know for a fact one of them is going to have to be an x, and one of them is going to have to be a 5x. I mean, just for the simple fact that it's a 5x squared. And then I've got a negative 3 here, so because it's negative, it makes it a little bit harder, but you know one of them is going to have to be a 1, and one of them is going to have to be a 3, and one has to be positive and one has to be negative. But to avoid that guess and check, if you remember, when I set up my t-chart, yes, I still need to add to negative 2, but instead of it being factors of negative 3, remember if we multiply here, so multiply the outside, so 5 times negative 3 is negative 15. If we find factors of negative 15 that add to negative 2, we're going to cut out a lot of this guessing and checking. So factors of 15 are 1 and 15. 2 won't go into 15, but 3 and 5 will. So which set does it have to be? Which is going to be the only combination that I can put together to get a negative 2? Well, how about 3 minus 5? So my 5's negative. Now, instead of these numbers going on the outside, like we did before, the 3 and the negative 5 have to go on the inside. And so then now, what am I going to do? GCFs. So 5x squared and 5x, what do these two terms have in common? They have a 5x in common. Now that I've got my starting point, I can fill out the rest very easily. So 5x times what is 5x squared? 5x times x. 5x times what is negative 5x? Negative 1. X times what is 3x? X times 3. And 3 times negative 1 is negative 3. So I have my dimensions, 5x plus 3 by x minus 1.